All right, so VSEPR is a very good theory for us to predict the geometry of molecules. We are talking about geometry of molecules, not geometry of electrons. So electrons की distribution, we will not go into that. This is just molecule के अंदर क्या bonds होती हैं, क्या angles होते हैं. Why is that important? It is important because when particles react, it is important कि वो कहाँ से एक दूसरे को एक साथ collide कर रहे हैं. They must collide with the right energy and they must collide at the correct angle. अगर उनकी ओरिएंटेशन ठीक नहीं होगी, इफ दे आर अप्रोचिंग फ्रॉम वन साइड एंड नॉट फ्रॉम द अदर साइड, एक साइड बहुत क्राउडेड है, दूसरी साइड पे अटैक करना था, इस साइड पे नहीं हो पा, तो उसका रिएक्शन कंप्लीट नहीं होता. एंड दैट हैज कॉन्सिक्वेंसेज फॉर हाउ द रिएक्शन प्रोसीड्स एंड इट हैज रियल वर्ल्ड कॉन्सिक्वेंसेज कि उसकी कॉस्ट, उसकी अरेंजमेंट, उसकी यूजेज, एवरीथिंग विल चेंज. So it is important to understand how things are arranged at the atomic level to make use of those things and also to make sure कि उससे किसी को हार्म ना पहुंचे. ओके, एटम्स की प्लेसमेंट से चीजों की प्रॉपर्टी चेंज होती हैं, प्रॉपर्टी चेंज होने से उनके यूजेजेस, उनके इफेक्ट सब चेंज हो जाते हैं. सो हाउ डज VSEPR वर्क? VSEPR is a model just like many other model. Like atom isn't actually like this. Hydrogen ऐसा नहीं होता. Hydrogen atom is just a cloud of electron moving around. But this model helps me understand कि अच्छा इलेक्ट्रॉन मूव कर रहा है, उसके सेंटर पे न्यूक्लियस है, एक इलेक्ट्रॉन है, and it's revolving around the nucleus. This model tells me a lot of things about hydrogen atom, even though this is not what hydrogen looks like. So these are models. We use models all the time in our life. Okay? And scientists make use of those models for better understanding. So VSEPR is also a model. इसमें लिमिटेशन होती है. अब कोई मुझे आके कि हाइड्रोजन एटम मुझे कैसे बताएगा कि हाइड्रोजन एसिड बनाता है, मैं डायरेक्टली नहीं बता सकता हूँ उसे हाइड्रोजन एटम से, बट उसकी लिमिटेशन है और उसके यूजेजेस हैं. ऐसी VSEPR के भी यूजेज हैं और लिमिटेशन है. नेक्स्ट ईयर A2 में आप देखोगे कि देयर विल बी केसेस जहां पे VSEPR फेल कर जाएगा एंड यू विल नीड टू इंप्रूव VSEPR समहाउ, बट वो A लेवल्स के सिलेबस में नहीं होगा कि VSEPR कैसे इंप्रूव करते हैं. सो आपको फिर नेक्स्ट ईयर A2 में ट्रांजिशन मेटल के चैप्टर में यू विल सी, जो भी टीचर होंगे आपके वो आपसे कहेंगे कि बेटा ये याद कर लें आप, बिकॉज उसको VSEPR को मॉडिफाई करना पड़ेगा और हम उसके लिए रेडी नहीं होंगे. But for our purpose, let's see what VSEPR is like. So what exactly is VSEPR? VSEPR is valence shell, which tells me that it's only going to be talking about the last shell. Electron pair. I'm not going to talk about individual electrons. I'm talking about electron pair, which are, in other words, I'm talking about orbitals with electrons in them. Repulsion. Now here's the thing. VSEPR applies to bonded atoms. और जो बॉन्डिंग होती है तो हाइब्रिडाइजेशन हो चुकी होती है. We get to VSEPR part after hybridization has happened. So the bond has been made. So even though we know that P is at 90 degrees to each other, P में तीन होते हैं, PX, PY, PZ, और वो आपस में तीनों 90 डिग्री पे होते हैं, VSEPR will show that that is not actually the case. And that is true. When the bonding happens, the 90-degree angle is no longer there most of the time. PX, PY, PZ की बजाय हाइब्रिड ऑर्बिटल्स आ जाते हैं, sp1, sp2, sp3, और उनके एंगल्स डिफरेंट होते हैं. What exactly does VSEPR talk about? VSEPR says electron pairs repel each other. So let's say electron pair होते कितनी तरह के? Electron pairs are of two categories. Again, I'm talking about valence shell electron pairs. There's the lone pair and there's the bond pair. Lone pair is pulled by one nucleus. Bond pair is pulled by two nucleus. So which one is more free? किस पे restriction ज़्यादा है?
Lone pair is more free.
Lone pair is more free. It has less restriction compared to bond pair. And that is why lone pair will usually repel more. It is able to float around in a greater region. So lone pair, I'm going to call it LP, repels more. So lone pair repulsion is greater than lone pair bond pair repulsion, and that is greater than bond pair repulsion. All right, so that's how they repel. So they are going to repel, but depending on which one is being pulled strongly by the nucleus, lone pair is more free, वो ज़्यादा freedom है उसके पास, ज़्यादा move करता है, ज़्यादा around region of space है, तो ज़्यादा area cover करता है. VSEPR says that all the electron pairs want to maximize the area in which they are available. उनका orbital चाहता है कि वो दूसरे orbital से दूर रहें और वो maximum freedom enjoy करें. And to achieve that, they will try to be as far away from the other orbitals as they can. So we will look at the central atom only. So I'm going to show you an animation for this. So as you can see, there are models and there are real molecules. Real molecules में चीजें थोड़ी सी वेरी करती हैं, but model को अभी हम देख लेते हैं. So this is a model of a very simple molecule. What I have here is one bond pair on this side and one bond pair on this side. अगर मैं electrons को देखूं तो electrons एक इधर share हुआ हुआ है, एक इधर share हुआ हुआ है, and that's how they are. There are only two electrons being shared on one side, either side of the purple atom. This bond pair wants to be as far away from the other bond pair as it can. तो अभी वो 180 के डिग्री पे है. ठीक है, मैं अगर उसके पास लेके जाऊंगा वो उसको रिपेल करेगा. मैं उसको if I try to follow it around, so उसको repel करता है, and it goes as far away as you can. So if it can move in 360 degrees, और दो चीजें maximum area, आपने 360 को दो में equally divide करना है. कैसे divide करेंगे? 360 over 2, right? So no matter how far it goes, it repels and maximizes the area that it can have by getting to the 180 degrees. So you have 360 degrees. You want to divide it equally. Clearly 360 over 2. Let's say I add another one. Now I have 360. And that I want to divide equally among three things. So what hoga? Clearly 360 over 3. 120 degrees. Now, if I added one more, what should happen? 360 over 4 होना चाहिए उसको. तो 90 degree होगा. But here, the atom thinks of something else. Atom is like, why am I working in two-dimensional only? Why is it that I'm only working in 2 dimensions? I can also have a molecule की height भी तो हो सकती है. I can go in 3 dimensions. And turns out, if it is in 4 dimensions, if it is in 2 dimensions, then it will have 360 over 4, 90 degrees. But if it is in 3 dimensions, और वो height gain कर लेता है, तो 4 के साथ उसका angle ज्यादा हो जाता है 90 से. It can arrange itself in a way that is 109.5 degrees. And this shape is called tetrahedral. So just because it's in 3 dimensions, उसकी एक height gain कर लिया उसने, उसकी वजह से उसको 90 की बजाय 109.5 degree का advantage हो गया. ज्यादा area मिल गया हर orbital को. And that is what it prefers. 3 में it was 120. So इस case में इसकी shape क्या होगी? If I were to join all of these, so I have made a triangle, right? That is why it is called trigonal. And because it's in the same plane, there's no height. We call it trigonal planar. If I go back to when it was just 2 of them, so if I were to join the edges, I will get a straight line. The molecule is joined through a line. So we call it linear. So the shape and the names are just straightforward. Okay, so I'm adding one more. Okay, 4 add kar liye maine. All right. What if I add one more? Ab ye 3 dimensions mein hai. So it has many ways of arranging itself. But here is one method that works the best. 3 of them will go in the same plane. As you can see over here. कोई भी 3 pick कर लो आप. Let's suppose मैं इन 3 को pick करता हूं. 1, 2, and 3. These 3 are in the same plane. They have formed a triangle behind the nucleus. मैं अगर थोड़ा सा इसको, let me move this around. Yeah. If you look over here, and let me join these now. So 1, 2, and 3. These 3 have made a triangle. In the center of the triangle, you have the nucleus. And you can clearly see that they are all in the same plane. And then the ones in the front, they have made uh, what another pyramid. So यहाँ से अगर मैं इसको join करता हूँ, let me join this. So if I join this here, I join this here, and I join this here. So using the red lines, you can see that this is a pyramid with a blue base. Let me try it one more time. I'm using pink color now. So with the pink color, you can see that I'm making a pyramid that is behind. Let me make it more clear. If I were doing this, yeah, let's see. So I have 1, 2, 3 at the side, and these 3 are forming the base of the pyramid. So do you see that this is a pyramid? It's a pyramid with a triangular base. That's why it's called trigonal pyramidal. Now, the same thing will happen on the left side as well. 1, 2, and 3. 2 pyramids, one on the left side, one on the right side, and these are triangular base. So इसकी वजह से हम इसको बोलते हैं trigonal bipyramidal. It's simple geometry. आपने सिर्फ उनके edges को join करना है, आपको ये मिल जाएगा. So the 3 that are in the same plane, वो बिल्कुल वैसे ही हैं. अगर आप इनको देखो, these are exactly the same as when I had exactly 3. तो उनका तो वही 120 degree वाला चल रहा है. And then I add 2 more, and these 2 are going to join on the left and the right. So these 3 are forming the same triangle, and then there's one on the left, one on the right. And then if I add 1 more, so that gives me this one. In this case, I have the maximum number of bonds that anything in period 3 can form. The maximum number of electrons that anything in period 3 can share is 12 in the case of sulfur. So here you can see that it has made 6 bonds. अब जरा मैं इनको join करके इसकी shape देखने की कोशिश करता हूँ. So my base is this. It's a square. Okay. And at the top, if I join it, I will get a pyramid. As you can see. Similarly, at the bottom, I will also get a pyramid. So I have 2 pyramids with the square base in there. So this is called square bipyramidal. But there's a better name that we have for this. Octahedral, because if you look at it, it has 8 sides, this shape. 4 at the top, 4 at the bottom. So this is octahedral. Clear? What are the bond angles going to be like? 90 degrees. You can clearly see कि इन सब का आपस में angle 90 है. Everyone is at 90 degrees from each other. So that is the main shapes, and I will tell you how to easily remember this. Now, does lone pair change things a little bit? If I add lone pair, then according to this model, it should make a difference. Let's say I have 2 of them. So it is 120 degrees. Why? Because lone pair is also acting like it is one more pair. That's all. It's going to repel them. And in this model, as you can see, this is repelling them equally. But that's not how real world works. In the real world, lone pair repels more. And in our syllabus, we're going to assume that it repels 2.5 degrees more. So the repulsion from the left and the repulsion from the right will be 2.5 degrees more. तो उसकी वजह से ये angle 120 में से 2.5 degrees कम कर दो. 117.5. And if I were to join this now, I will get this shape. I don't have a line now. I have a bent shape here. And that's what it's called, bent. Let me add another lone pair. Let's say I add one bond pair. So now I have a lone pair and I have three bond pairs. How does VSEPR explain all of this? और अगर मैं इसमें से एक ये remove कर दूं और ये कर दूं, how does VSEPR explain this? So for all of that, let's go back to the basic model and let me tell you something. We are going to treat bond pairs and lone pairs as electron dense regions, electron rich areas. That's what we're going to call them. I call it EDR. It does not matter whether I have a double bond or whether I have a triple bond. This is one region which is electron rich. This is one region that's electron rich, and this is one region that's electron rich. And because these electrons are being pulled by the same nuclei, my model is going to assume them to be equal in terms of repulsion. पहली बात तो ये होगी. So EDRs are what we're going to look at. Lone pair is one EDR, single bond is one EDR, double bond is one, triple bond is one. And lone pair is going to repel 2.5 degrees extra. ये दो बातें आपने लेके चलना. Okay, so let's look at an atom with just two EDRs. Two EDRs, 360 divided by 2, 180 degrees का angle होगा. Now let's take another one. 3 EDRs. Now it doesn't matter whether you have double bond. आप double bond लगा दो, ये भी 3 EDRs है. आप triple लगा दो, ये भी 3 EDRs है. आप एक double और एक triple लगा दो और एक single लगा दो. 3 EDRs हैं. It doesn't matter कौन सी bond है. 3 EDRs हैं इसमें. So right now I have 3 EDRs. The repulsion should be 360 over 3. 120 degree angle on चाहिए. But if I have 3 EDRs, but one of them is lone pair. 3 EDRs पे angle क्या था? 120. But if I add a lone pair, so it will be 120 minus 2.5. 117.5. ये मेरा angle होगा. Okay. Let's go to 4 EDRs. 4 EDRs में my angle is 109.5. Now let me remove one of these and add the lone pair. मेरा angle 109.5 minus 2.5 हो जाएगा. And it will be 107. As is the case in ammonia. 4 EDRs हैं. एक lone pair है तो 2.5 कम कर दो. What if I have 4 EDRs but 2 lone pairs? 4 EDRs का angle है 109.5. एक lone pair से वो 2.5 कम होगा 107. With another lone pair it goes 2.5 degrees less, 104.5. That's what we have. Water. Clear? And that is how we use VSEPR. We can go forward, like what if I have 5 EDRs and one of them is lone pair, or 5 EDRs with 2 lone pairs, but that's not in our syllabus. In our syllabus, we just talk about, okay, I have 2 EDRs, 360 divided by 2. I have 3 EDRs, 360 divided by 3. One of them is lone pair, divide by minus 2.5. 2 of them is lone pair, वापस वहीं पे आ जाएंगे हम, 180 पे आ जाएंगे. अच्छा. 4 EDRs, angle is 109.5. One of them lone pair, minus 2.5. Another lone pair, minus another 2.5. And it doesn't matter whether it's single, double, or triple. It is a linear electron dense region. That's all there is. So if I were to like summarize all of this, whatever we have seen so far. So EDR is what we're looking at, electron dense region, which basically means कितने bond pair हैं, कितने lone pair हैं, सारे electron pairs बता दो मुझे. जो कि वहां पे हैं, कितनी bonds हैं, कितने lone pair हैं. That's all. Let's say it's 2. 1 पे तो 180 होगा. तो उस पे angle between one bond and the other bond. We are always looking at the bond angles. We are not looking at electrons के angles, क्योंकि वो तो fix ही रहते हैं. So the bond angle is going to be 360 over 2, 180. What's the shape going to be like? It's going to be a straight line, linear. What's an example? carbon dioxide. I have 3 EDRs. 360 divided by 3, 120 degrees. The shape is going to be triangular or trigonal, and it's no height in there. Trigonal planar. That's what I have here. An example, AlCl3, BF3. How many lone pairs in this? 0. What if I have one lone pair but 3 EDRs? दो bonds हैं एक lone pair. 120 minus 2.5. 107.5. Example, SO2. SO2 में क्या होता है? S, double bond here, one lone pair. 3 EDRs हैं, and one of them is lone pair. So 120 minus 2.5. Why 120? 3 EDRs में होता है 120 है. एक plane में रहना है. What if I have 3 EDRs but 2 lone pairs? तो वो 115 हो जाता है. But then वो 115 की बजाय वो है ही एक बॉन्ड, तो वो उसका किससे दूसरी बॉन्ड ही नहीं है कोई, तो इस वजह से उसका एंगल 120 ही हम लेते हैं. Okay, I have 4 EDRs now, 0 lone pairs. So the angle is 90 if I keep it in one plane, but I can achieve a better angle by giving it a height. So 109.5. How do you get that? उसकी geometry हमारे syllabus में नहीं है कि मतलब कैसे आता है, हमें नहीं पढ़ने की जरूरत. Example, CH4. कार्बन है, 4 बॉन्ड्स हैं. डायमंड में भी यही होगा. बाय द वे इसकी हाइब्रिडाइजेशन क्या होगी? 4 ऑर्बिटल्स हैं एक जैसी बॉन्ड बनाते हुए, 4sp3. Get it? Hybridization is related to this. Yes.
Sir, the one which has 2 bond pairs and 1 lone pair, उसकी क्या hybridization होगी?
2 bond pairs and 1 lone pair. So
Yeah.
that is sp2 होनी चाहिए उसकी.
Basically, हम lone pair could be like a.
Yeah, lone pair is also part of the hybridized orbital now.
Okay. And sir, एक और चीज, how do we figure out कि like इसमें lone pair है कि नहीं?
We just draw the Lewis dot diagram. Lewis dot diagram जो इसको आप dot and cross diagram बोलते हो, या जो basic structure होता है molecule का, जैसे methane में ये है. अब मुझे पता नहीं है कि इसकी, let's suppose मुझे नहीं पता इसके angles क्या हैं, बट मुझे ये तो पता है कि central atom के पास कोई lone pair है या नहीं है. तो इसमें तो नहीं है.
So what about like NH3? तो like nitrogen हमें
Let's
पता
do
है.
it. Nitrogen 5 electrons होते हैं, it has shared 3, so 2 electrons रह गए. So there you go.
So that would be like one lone pair.
4 EDRs, 1 lone pair.
ठीक
So
है.
109.5 minus 2.5, 107. So this shape is going to be slightly bent. मतलब ये 90 नहीं होगा, bent हो जाएगा. So it will be like this. And the angle is there. And if I join this, तो मेरे shape क्या बनती है? It's a triangular base और pyramid बन रहा है. So इस वजह से इसको हम trigonal pyramidal बोलते हैं. Trigonal pyramidal. All you have to do to find the shape is draw this and join every atom on the edges. आपके पास एक shape बन गई. See it?
Sir, I'm
Triangular
so
base वाला
sorry.
pyramid बना हुआ है.
So could you also do it for water?
So I have 4 EDRs but 2 lone pairs. कैसे? Let's see. Let's start here. Oxygen, hydrogen. मुझे नहीं पता जी oxygen के साथ angle क्या है. But I know that oxygen has 6 electrons, 2 of them in bonding, 2 of them left over, right? So clearly I have 4 EDRs and 2 of them are lone pairs. So 4 पे 109.5 होना चाहिए था. I'll deduct 2.5 twice. So 109.5 minus 2.5, 107 minus 2.5, 104.5. So this shape will be, okay, it will be like this. So if I were to join it, I'm getting this, like a boomerang. So this one is a bent shape. Okay, this is also called bent shape, by the way, sulfur dioxide wali. If I have 5 EDRs, तो उसके lone pairs हमारे syllabus में नहीं है. Similarly, not for 6 EDRs. उसके lone pair हमारे syllabus में नहीं है. So 5 EDRs में 3 of them are in the same plane, and one is at the top, one is at the bottom. So इनको हम बोलते हैं, this is 90 degree for the ones at the top and bottom, and 120 degree for the ones in the same plane. And in 6, there are all of them at 90 degrees. The shapes are octahedral, as I shown कि वो square bipyramidal थी, तो उसको octahedral बोलते हैं, and this one is trigonal pyramidal, bipyramidal, because triangular base hai. So an example of this would be PCl5, and an example of this would be SF6. This is very useful, especially when you dissolve metal ions in water, because water उनके साथ bonds बनाता है और उससे हमारे पास इसी तरह की different shapes आती हैं. There are cases where this does not entirely work, and especially when you have solutions. But VSEPR can be improved to meet those challenges. We don't study it in AS though. कि अच्छा VSEPR को improve, useful model for us to figure out कि इसके angles कैसे होंगे, इसकी shapes कैसे होंगी, and that allows us to figure out कि react कैसा करेगा. And yeah, that brings me to the end of today's lesson. Okay, thank you so much.